Hey, I'm Roman, and I'll just try and make this one quick. Honestly, I was trying to stretch out for about half an hour, but going over time really.
I've got poor time management skills, so don't need to cover up most things.
Yeah. I want to introduce you guys to the CoAP protocol, or the CoAP protocol, or the CoAP protocol. Take your pick. Before we get into it, I just kind of want to discuss the other IoT protocols that are kind of commonly used, like HTTP. So it's by far the most popular protocol with the largest share of internet traffic globally. Citation needed, but who would disagree? There are quite a lot of HTTP servers available for most platforms. For example, there are 6 Wi-Fi devices, the ESP8266, that can fit in just about of anything. There's a lot of support for the protocol, commands, tools, code generators, some really nice APIs for handling and consuming the data. Security is for the protocols also handled over TLS, which is trivial to implement. You just pull in the library and turn it on, and Bob's your uncle. Not to mention that HTTP2 requires TLS for browsers that currently implement it. Clear text. So HTTP is very much clear text. So the headers are also clear text, require some processing, which is not very easy on resource-constrained devices that need to uphold a lot of it in the memory to process. You have to deal with the public key infrastructure, which can be difficult to manage. And because the devices may not receive updates when running from a factory fresh image or after a few years, so you install it, wait a few years, factory reset it, certificates expire. You're kind of screwed. You'd also need a server that has a certificate that doesn't expire for a long time to guarantee that the devices don't work after a long period of time. So you have security issues with that. Yes. For some reason I mentioned poor data type throughput. I've got no notes on that one. Something along the lines of you have to poll for the data. The device won't tell you when the data is available unless you've got WebSockets implemented. Or there's also something else similar to SIP. I don't know what it was.
SIP, so I was already vitally ill.
Yeah. On the other hand, we have MQTT, which is a message queue telemetry transport. It's also an ISO standard, much like EchoNet Lite. It's a publish-subscribe protocol, so the device itself will publish a message to a broker, and then the broker is responsible for pushing the message out to everyone who's subscribed to it. MQTT can also be a machine-to-machine protocol, so each device can also be its own broker, so you can actually subscribe to a device directly, and when it pushes data, it'll push data out to you. The broker is just a means of delegating that responsibility to something more central. Since MQTT is a message queue, there's not really any standardized way of discovering topics available on server. Well, it kind of is, but it's not you can discover the topics available, but you need to have prior knowledge as to what those topics are or how to read them. There's no way of reading schemas available for those data types or filtering by data types. MQTT also has a weaker security model that doesn't use PKI, instead just uses a client ID and secret, which is to encrypt the protocol, so that if you got those credentials wrong and try and connect to the server, it just looks like a connection error, and your server just goes, I don't know what that is.
So Robert, just to confirm, so MQTT actually encrypts data with the key, so it can't be decrypted plainly, is that right?
Yes.
Cool.
So it encrypts the entire protocol, but it's not in a way that you have to. It's not an authorization sort of method. Yeah. So
it's all or nothing.
It's all or nothing. So you can't detect brute force attacks because you can't tell who's trying to talk to you unless you've got the credentials right. MQTT. It's a push sort of thing. As for EchoNet Lite, well, thank you to Hito and Futo.
Thank you.
There we go. Right, so CoAP, or CoAP, I don't actually know how it's intended to be pronounced, is an IETF proposed standard by the Constraint RESTful Environment Working Group, or CORE, or CoRE.
There's a thinking of their naming, isn't there?
Yeah, the CoAP protocol is abbreviated from the it's abbreviated the Constraint Application Protocol. I keep saying CoAP protocol when protocol is actually the last letter. It's a machine-to-machine friendly protocol designed around REST APIs with your favorite get, put, post, delete, and verbs. Sorry. It also offers the observe verb, which is for, unlike MQTT where it's a publish subscribe, observe is the device is directly responsible for publishing the data to you right away. So if a resource needs to be kept up to date, if you want to get a resource, it'll say, hey, I'm observable, and you can go, cool, I want to observe it, and the device now will tell you every time that resource changes. My favourite part about CoAP is the support for multicast discovery. So much like how Ethernet Lite had a multicast IP address that you could send a packet to and everything will respond to that, CoAP also has a multicast IP address that you can say get request to, and all devices on the network that support it will respond with those resources. It's very much like multicast DNS in the way that you go, who has this DNS name, the device is responsible to have it, do the same thing with a get or well, you could do a put or a post. Security is implemented through DTLS, which is a fancy way of saying datagram transport layer security. It's just TLS but over UDP. The biggest problem with DTLS is the lack of implementations for it. So my favorite programming language is .NET or C#, which doesn't actually have DTLS support at all, which is mildly concerning. There are a few other libraries that will support it, but it's not as a big a player as TLS. The other problem is, well, public key infrastructure. You have the same problem with HTTP of having to deal with certificates to authorities or expiring certificates. You can do pre-shared keys a bit more, probably. I won't go into too much detail about that. There's actually a lack of tooling and support for CoAP because barely anyone's heard of it. Like I'm sure most of you guys have never heard of it apart from me mentioning it once in a while.
So it's still a standard of discussion, it's not finalised?
Oh, it's finalised. It's been out for quite a few years now. Okay. There's actually two very big specs built around that you may have heard of, which I'll get to that later. So one of the first tools that I use quite often is a Firefox plugin called Copper. That you can only run on Firefox Quantum. So you have to run an outdated version of Firefox to run this plugin because that's the only nice looking tool out there, and Quantum changed their API plugin stuff. The next one up is a nice CLI tool called CoAP Client, which is from a library called libcoap. The most well-developed CoAP library out there is called libcoap. Sorry, I keep pronouncing CoAP and CoAP wrong. That's just me doing a GET request to a server, which is coap.me. It's a public testing service. You can test your implementation, see if it works. It's just a simple response. And quite recently, I found out an Android app called IoT CoAP, which is early days still because it doesn't do much apart from those two screens you see there. So why CoAP? It's RESTful APIs. That's the thing that stood out the most. It's a familiar programming paradigm with plenty of existing design tools and patterns for using and consuming REST APIs. For example, OpenAPI, which is formerly known as Swagger, which I'm sure most of you have heard of, lets you quickly form an API backed with code generation for a multitude of programming languages. It's also easy to migrate existing APIs over to CoAP. For example, servers that are already HTTP, since it's REST, HTTP easily migrates over to CoAP. Unfortunately, CoAP, well, much like Ethernet Lite, it's a lightweight REST API. It's not designed for streaming media, so images and video content and other large data packets aren't designed for CoAP. I just need to point that out. Discoverability is, well, for me it was a huge one. Typically, each CoAP server will have its a thing called a .wellknown core resource. So you do a multicast get request for the well-known core, and all devices that support it will respond to you saying, hey, I'm here, I have these resources. Those resources are, it's metadata about all the resources, so where the URI is, so if it's /lite or /room then /lite, you'll get all the information right away, including schemas if they have those public listed somewhere, or any other information you might need to know how to talk to those resources. Even resources you've never seen before, it might come with enough information that your app or application could figure out how to talk to it. That's why I like CoAP. These sort of things are figured out. The well-known core resources based on the core, the link format, The well-known core resource uses a core link format identified as application link format, or application/link format. It derives from HTTP's link headers, if any of you have ever seen those, which provides a client with metadata for the resources being served, yada, yada, yada. I've just said all that. It also supports filters, so if you do a get with a query on it, you can say, cool, do a .wellknown core, resource type, temperature. So only devices that have a temperature resource will respond to you. So you can quickly get an idea of all the temperatures on the same network as you, without even knowing that they were there in the first place. So that's the nice factor of discoverability.
So you post it to a multicast address? Yeah,
you post it to them, you still do a get request to the multicast with a query, resource type equals temperature, and then all the temperature all devices that have a temperature will respond. There is a problem with the multicast, so that the devices have to always be listening. So there is actually a draft that's in progress that's very close to being finalized called resource directories. And that's very much like an IoT hub, and I'll get to that later on. As I mentioned, security can be implemented through DTLS, like most APIs. That needs to be considered, and this is stuff from my previous talks, not really relevant. Observable resources, so this is actually something I quite enjoy. That is, resources follow the observer pattern, so any programmers out there who understand what the observer pattern is, much like reactive programming is all observer patterns. The client needs to send an observe request to each resource, and the server will become responsible for notifying all subscribed clients each time the resource is changed. There is a draft also in progress, so the CoRE are working on a draft publish subscribe part of CoAP, very much like MQTT, where you just publish those resources to a broker, and the broker will then push them out to anyone that's wanting to listen. Group support has just been finalized by CoAP. Due to the nature of IoT, you kind of end up with a lot of devices in a single room that often responds to similar events. So group communication for the constraint application protocol provides an approach to using CoAP over IP multicast. In summary, multicast requests to coordinate multiple devices to perform the same action. For example, turning on all the lights in the rooms. Each light has its own unique IP address, and you're all subscribed to the same group. So you put them in the same group. So you just say, cool, this group, do a post on, and then all the lights will go, alright, I'll turn on for you. Resource directories. So as I mentioned before, resource directories are still in draft, but are widely used already by the two specs that I mentioned. So lightweight M2M, or LW M2M, and open interconnect, or OIC. Those are two commercial specs that I'll touch on shortly. Resource directories keep a record of resources that are available on neighboring devices. So you can think of them as IoT hubs, keeping track of their devices for you, much more, sort of like a federated manner. The idea for a resource directory is that you have low power devices that you don't want on all the time, draining battery or listening to the Wi-Fi all the time because it could be draining the battery. So a resource directory will advertise itself as a resource directory. So when the device turns on and go, hey, are there any resource directories nearby? One of them will go, yes, I have this thing, and go, cool, I have a temperature sensor and a light sensor and a thing, here are my addresses, sends it to the resource directory, and then the device turns off. Or it goes into a very low power unicast listening mode, which Wi-Fi spec I think supports. If you send a direct message directly, it'll wake it up. So the device that's always on and always listening will go, hey, light sensor, temperature sensor over there, and sends it off to the mobile phone. So the resource directory becomes responsible for keeping track of devices for you. As for the specs, it's UDP based. It's on port 5683.
Seems like UDP and multicast are super popular for these kind of things.
Yep, that's the multicast for IPv4. For IPv6, it's FFOX, X being any class. I don't quite remember what it meant, but it's like how many layers or how far out into the network do you want to ask for who's out there. And packet sizes are usually 4 bytes long. It's very short, very small. It's a very easy encoding method too. 4 bytes is, So that's the core part of CoAP. There's more to expand itself. At the moment, core are still working on more drafts, 2 commercialized specs I can talk about. As for the drafts, you've got the pub sub coming out, which mostly useful. For those who are familiar with MQTT, you can just start working with the pub sub part and then slowly migrate over to using the REST API, if that's what you feel like doing. And then there's the core object security, which is very much like JSON web tokens. So you have objects, you can either encrypt them and sign them so they can't be tampered with, or you can just have them encrypted or just signed. You take your pick. It's a draft that's in progress that'll soon be finalised. You can use it now if you want. It'll just be a few minor changes because it's well into the lifetime. It's close to being finalised. There's actually quite a lot of drafts happening at the moment. I mean, that's only 1/3 of the page. There's more down there. Open interconnect. So it's actually a rabbit hole I went down. Very much like Econet Lite, it provides everything for you. Everything's well thought out. It's backed by the Open Connectivity Foundation, which is an alliance of big named companies and manufacturers, so not very friendly to the open source community. The specification covers everything about IoT, including provisioning, ownership, maintenance information, security, access control, grouping, scenes, device types, resource types. It's very extensive. They even have a open source part of OIC called IoTivity. If you've heard of it before, it's a development platform for OIC that lets you emulate devices and provides frameworks for Arduinos and such. The problem with IoTivity is that everyone who's working on it is someone who's employed by one of those big name companies. They're not actually members of the community. They're sort of employed to work on it. I've looked, I can't find any real open source channels or information. You can just go, hey, here's a feature request. They go, oh, who are you? So the one that I'm more in favour of, what I've just heard about, is the Open Mobile Alliance Lightweight M2M, or
There's rolls of the tongue, eh?
yeah. Also based on CoAP, uses resource directories. I should be reading that. Has its own registry of schemas and resource IDs. So again, much like Econet Lite, but you can quite happily register your own ID to say this is a light device type, or this is a washing machine, or whatever. It's a very nice looking, well, it's friendly, not nice looking. It's still based on XML schemas, if any of you like those. Yeah, I don't know much more about it. I still need to do research into it because I just found out about it, even though it's technically older than Open Interconnect. Yeah, like if you do a search on Showdown, you get a lot of these servers just sitting there doing nothing. And finally, I'm actually building my own cross-platform tool called CoAP Explorer. Still early days, meant to be cross-platform. It's going to be running on, it runs on Windows at the moment. I'm working on the Android version that uses the same code base, and I want to move it to Linux as well. I would say I want to move it to iOS, but I actually own 0 Apple devices, so it's kind of hard to do that. I probably could do a demo of it, but effort. Yeah, like I said, very quick overview. So, questions? No?
How can you use it?
How do you use it?
Yeah, how can you use it? What can you use it? Is it like an MQTT server or type variant or?
So there is a HTTP to CoAP proxy service that's also part of the spec. So it's a guideline on how to port them over. I did show you here that there is, if we can zoom into that one, there's a test server which is coap.me. You can start talking to that to test it out. You can spin up your own Arduino. There's already CoAP libraries for Arduino and other devices out there. So libraries for the embedded devices exist. It's just that it's not real tooling for the desktop or servers because it's not really. It's more designed for the low-end embedded hardware, not for the high-end stuff. Because high-end, you just already got HTTP, why bother? But there's no tooling for it because no one really thinks about tooling. You just go, well, we'll just test the devices they already have.
Is there much in the way of like shipping manufacturers using this, like products on the shelf?
Already products.
So the Trafalgar, I think it's pronounced, which is the IoT light from IKEA, that uses the CoAP over DTLS, surprisingly. Yeah, so that took ages for people on the internet to figure out because they'd never seen it before, but I sort of recognised it right away. There's a very high-end advanced IoT speakers that use it. I can't exactly name them at the moment because there's a huge security vulnerability with them right now. Yeah, it's more of what you find on Showdowns. There's a lot of AWS servers that will list them as the lightweight M2M variant, but it's still CoAP underneath, and you can talk to them using their Firefox app or even my app, which is functional.
So those AWS servers, are they people running collection points for other CoAP and stuff in the world, feeding it to their own companies, or is that?
Yes and no. Actually, in Russia, a lot of the routers use CoAP as their configuration maintenance endpoint.
I can't remember as TR69, so.
I don't remember what they were, but they're sitting there. Sorry, I'm also a security researcher, so I find these things all the time.
Research purposes.
It's amusing. Yeah. I don't actually know any other devices. I actually tried asking people, hey, does anyone know any CoAP devices out there? And didn't get much of a response. So it's unknown, but the reason why I like it again was because it's a REST API. You've already got tooling for designing REST APIs and consuming REST APIs. So it's a low-level barrier to migrating to CoAP. Yeah. It's just the DTLS part's a little hard, so which is why I'm betting on that object encrypted signed object thing, which I hope comes out soon, because that'll be a good way to protect your data while it's in transport. Yeah. So like it's very short. Sorry for taking your time.
Awesome, well thanks so much, Roman.
Yeah,
Appreciate that.
that's me. Just search for these.